Welcome to Crying Out Cloud, the podcast that will make you laugh, cry, and reconsider all of your cloud security fears. I'm Eden from the CTO team at Wiz, and I'm here with my amazing co-host Amitai.
Hello.
We are super excited to keep you up to date on what's happening in the cloud. Without further ado, let's kick it off. Amitai, what is happening in the cloud that we will be covering today?
Today we will be talking about how Wiz Research discovered a vulnerability affecting Nvidia Container Toolkit. As you can see, Wiz is doing a lot of work on AI vulnerabilities. So if you are developing with AI, you better watch out. We're going to be talking about the CUPS vulnerabilities that everybody's been talking about. And we're going to be talking about how printing is something that you should not be doing because you should be protecting the environment and you should not be wasting paper. We're going to be talking about how Google have been trying to mitigate the effect of Infostealers in Chrome and GCP, and they're doing God's work. We will be talking about how there have been a few cases in recent years of CSPs being vulnerable to dependency confusion. We'll talk a bit about what that means. We'll talk a bit about why that's concerning. And finally, we'll talk about Atomic Cloud IOCs, why they are important, and why we have chosen to highlight them in a recent blog post.
Okay, Nvidia. So Wiz has done a lot of research in the vein of protecting AI, and in doing so, they found a vulnerability that affects container toolkits. It is a very popular instance. So you have something like 30% of cloud environments using it, and over 2,000 stars on GitHub. So this affects companies that build with AI and offer AI as a service because you are likely training your AI over an Nvidia GPU. May or may not be, but there's a good chance you are. And how does it work? Amitai, can you explain the vulnerability?
So in essence, the vulnerability can be exploited by either convincing someone using an NVIDIA GPU and using Container Toolkit to run a specially crafted malicious image. So basically the attacker builds the image in a certain way that exploits the vulnerability, convinces someone else to run it. Okay, and when they do, they can have a script, for example, on the image that escapes the container and then gains code execution on the underlying host. That's one way to go about it. And the other way to go about it is if, for example, you have access to a cloud environment, and let's say you can control a container image registry. Let's say you can edit existing images, so you can replace an existing image that you know is in use with your malicious image. So in that case, there's no social engineering involved. It would just be exploiting prior access. And the third way that this might be exploited is in shared environments where, let's say, a company allows anyone to run a container image that they bring, from their home. So in this case, just by allowing anyone to run a container image, they'd be able to escape their container, reach the underlying host, steal whatever they can find there, and also be able to access other customers' containers. Because once they have access to the host, they can access anything.
That's super scary. Like if it's multi-tenant, you could literally steal other customers' data.
Yeah.
Crazy. So you should know by the time we're recording this, Nvidia has actually fixed it really fast, which is awesome. And Wiz Research continues to work on it and other things in this domain. You should definitely patch this if you are susceptible. Are there any other takeaways they should be aware of, Amitai?
Yeah, so I think it's important to know that this toolkit comes pre-installed in a lot of cases, meaning that you might have it installed, but you're not actually using it. So obviously you should prioritize patching in places where you are using it. And secondly, you should be patching it in places where you think there's a high likelihood of using images that are untrusted. such as the example I gave before of if you allow anyone to run container images just arbitrarily, then those servers are the places where you need to focus your patching efforts.
Okay, for our second story, we are going to talk about vulnerability that was found in CUPS. So, Evil Socket found a vulnerability in CUPS, which is a printing system, and they found it, and then they tried to like hit up the maintainers and be like, "Hey, I found this," but the maintainers were not so convinced nor moved to action. So they took this, they went public with the information, not with the details of the vulnerability, but just saying that they had found a significant vulnerability, which really added hype, raised people's alarm, and no one knew exactly what it was, which I think also really added to the hype circle. And then one Thursday, they published it within a few hours of announcing that they would, and the drama kind of ensued. What happened after that, Amitai?
So people were sort of expecting this to either be insane, like the worst vulnerability ever, or a nothing burger. Um, and it turns out that it is neither. Um, it is a very interesting and useful vulnerability that is exploitable remotely in very rare cases.
So, what is the vulnerability specifically? How can it be exploited?
So it's pretty cool. The vulnerability is essentially um, the ability to register a malicious printing server um, just remotely over the internet. Um, so if you are publicly exposing um, uh, your internet printing protocol server over the internet on port 631 UDP, someone can connect to that and basically just register a printer or replace an existing printer that you already have with one they control. And then what happens is that if someone on the compromised host were to send a new printing job, then that would trigger the vulnerability and allow the attacker to remotely execute code on the host.
And the elephant in the room is that you must print, which is so niche. And I don't own a printer, and so few people own printers. And on top of that, so few people use Linux systems as their personal computers. So, like, you have to be all of the above.
Yeah, and you also have to expose this on port 631 over the internet or another port, doesn't matter, but people are going to be looking for this on port 631. Um, yeah, so it's like the stars really have to align for this to be exploitable remotely. On
Yeah,
the other hand,
it's going to be exploited remotely if currently.
yeah, but it's probably not going to be exploited remotely like within organizations. It's going to be exploited remotely just uh, like for example on maybe routers or maybe just like really weird hardware that happens to have this installed by default. But in that case, people aren't necessarily going to be sending printing jobs. Now, the way where this becomes a bit more interesting is alongside other capabilities. So, for example, if someone um, already has access to an environment, they could use this vulnerability as a sort of backdoor or as a persistence mechanism because they could basically install a malicious printer on a computer that they already have access to, and then they could trigger print jobs themselves discreetly um, in a way that's transparent to the user, and that would execute execute their commands. So it might be interesting to see like how this is actually used a bit more creatively than just scanning the internet for compute that's publicly exposed on this. But as you mentioned, like most people aren't going to be printing. Most people aren't going to be printing from Linux, and in the cloud in particular, which is where we focus, um, you're not really going to have any printers in the first place because it's all virtual machines, and I highly doubt you're going to have people printing from VMs to physical printers, at least not commonly. And this was definitely overhyped. If the drama had not, uh, you know, gone on as it had, it's possible this vulnerability would have been added to, added to NVD, and nobody would have really cared about it. Like nobody would have been talking about it. But I think the drama made it get a lot of attention, more than it's supposed to have. Um, it's definitely gonna be exploited. It's just that there are very rare cases where it can actually be
Correct.
exploited.
So, all to say as a takeaway, hash if you can. And if not, don't print, don't or disable cups, or don't expose cups to the internet. So for our third story, we have the Chrome and GCP Infostealer protection. Two separate efforts, super commendable. Still TBD if they'll be adopted and work as expected, but we're going to tell you about them. The first one is addressed towards Google Chrome. It's an app-bound encryption. The goal is to encrypt cookies and store passwords using a Windows service that runs with system privileges. It's pretty much what I just said is that credentials, Chrome puts them in the storage away from info stealers. But and the big but is that they did this, and then 2 days later, info stealers found them nonetheless. So there's a bit of a back and forth. We're going to see where this falls. Amitai, any more context here, or this is still a big, we'll see where this goes.
Yeah, so Google sort of set the bar here for first threat actors, basically saying like, we've come up with a way to prevent info stealers from stealing stuff from Chrome, and then developers of info stealers saw this as a challenge. They rose to the challenge, and then like very very quickly they figured out how to bypass this. But on the other hand, this might be seen as a failure. This might be seen as a bad implementation of the idea of outbound encryption. Like maybe Google just needs to work out the kinks. But they have said, and I found this interesting, that what it has succeeded in doing is making sort of creating a bottleneck that threat actors now have to move through if they want to steal credentials from Chrome. So even if it didn't prevent it from happening entirely, it makes it so that threat actors have to do so in a certain way that is more easily detectable than it used to be, which is pretty cool.
Super cool. And definitely the right direction. The second one they did was GCP implemented certificate-based access. It's a security measure that leverages mutual TLS, and then it works to ensure that user credentials are bound to a device certificate before then they then go authorize access to cloud resources. This is awesome because it, in theory, prevents access to stolen credentials. It's a good protection against cookie theft. What else is it good for? It renders stolen credentials useless, verifies devices for every access request. So all in all, pretty good. How does this work?
All right, so the way this works is that it's taking advantage of a TPM. A TPM is basically an area um, uh, of the computer that the user cannot access. And it's often used for cryptographic operations. And the idea here is that you have a certificate stored within the TPM. And in order to connect to GCP, you need to have both that certificate within your TPM on the computer you're working on and your credentials, because your credentials are signed using that certificate. So if a info stealer would only steal the credentials, then they would be rendered useless, as you mentioned, because they'd need the certificate from the TPM in order to make them work. And stealing from a TPM is a much, much harder problem that is considered not really feasible today for info stealers.
So all in all, like these are still like we're gonna watch these still develop and roll into action and adoption, but note that they are out there. Note that they are very, very commendable and worthy improvements in the cloud that we are happy are coming.
Yeah, like it remains to be seen if people are actually going to use CBA. Like I think it'll be really cool if it becomes really popular, and if it becomes widely adopted and everybody uses it, and maybe even it'll be adopted and used in others for other CSPs as well. Um,
Share the love. Show the CPA love.
And for the Chrome thing, um, I think it's already enabled by default. So like everybody using up to date Chrome can benefit from this. But again, like this will depend on like the cat and mouse game between Google and Infostealer developers.
For an extra, we have dependency confusion vulnerabilities affecting CSPs, namely Cloud Imposer, which recently took place. It is a vulnerability where a misconfigured system automatically picks up unintended libraries. So Google misconfigured how packages were compiled, which allowed malicious libraries to be injected into Cloud Composer and other services. AWS had a similar issue a few years ago. Amitai, can you tell us, first of all, just for context, what happened with AWS, and then also how they leveraged injecting into Cloud Composer?
So in the AWS case, it was security research that showed that there were a few packages AWS was using that were removed. And then researchers showed that they could basically hijack those package names and which would in theory lead to AWS ingesting them and using them as part of their development. As far as I remember, the results there were sort of inconclusive. Like we know that those packages appeared to be susceptible to dependency confusion. We don't actually know if it succeeded, if I remember correctly. In this case, it was proven by the researchers that that they got pretty far. Like they saw servers reaching out to servers that they set up to test this, which meant that there were definitely systems using and ingesting these packages, even though they're not supposed to. So confusion dependency, which I went through before, is basically where you have a package or a library that you want to import when you're compiling software. And instead of importing package A, it imports package B, where package B is just could be anything. But in the worst case, it's a piece of malware that someone has actually set up specifically in order to take advantage of the fact that you, as a software developer, are not properly validating which packages and libraries you're using.
Mm.
Um, this can happen, for example, if you have a typo in the name of the package that you're importing. It can happen if you're not configuring properly your CI/CD system. It can happen if you're using private packages, but you're not reserving namespaces on public registries. Like there are a bunch of different ways for this to happen. In this case, in the Google case, they had misconfigured their software pipeline to basically always use um, a library that would be publicly available as
Mm-hmm.
opposed to a private library, which is sort of a very classic dependency confusion vector. And then once they realized this, the researchers, they just set up fake malicious libraries with the same names as what Google were using, and then they basically saw Google ingest those.
That is incredibly savvy of them.
And this was stuff that was listed in their docs. Like they just went to Google's docs, they saw these are the packages that we're using when we're building Cloud Composer.
Mm-hmm.
They checked which of these packages were publicly available, which were not. The ones that were not, they assumed correctly that they were private packages. They registered packages with the same names on Pipey, I think, and then it worked.
And the last story is on Atomic Cloud IOCs. So we talk a lot about here about things after the fact, because that's what we do, our news podcast. But we would love to take a few minutes to kind of talk about how you can continue to be keen and alert to critical cloud IOCs. Amitai, can you tell us how cloud defenders can prioritize cloud specific IOCs and what they look like how they've transitioned from what we used to look for versus what's new and fresh, which should be on people's radar?
So I think when people talk about IOCs these days, they're usually thinking about file hashes and network IOCs like domains and IP addresses. That's like what people typically mean when they talk about IOCs. And we recently put out a blog post, the first in a series on IOCs in the cloud. where we focus on atomic IOCs in the cloud. And by atomic, we mean IOCs that are highly specific, things like file hashes, things like domains. They're equivalent in the cloud. So when you're working in the cloud, there are other IOCs that are sometimes even more significant than the ones I mentioned before, such as account IDs and resource names. Um, these are things that you're going to be working with a lot as part of threat detection in the cloud that, again, can sometimes be even more significant and even more prevalent than IP addresses and file hashes. And the industry these days isn't especially adapted to this reality, like in the sense that if you see like a blog post or a threat report about some threat actor,
Mm-hmm.
and you look at the IOC appendix, you're not going to see account IDs or stuff like that, even though the threat actor might be active in the cloud. And I feel like a lot of companies don't necessarily highlight these things enough or are aware enough that they can be useful for detection, that they aren't just anecdotes, that they can actually be translated into detection rules. So our blog post was kind of an attempt to bring attention to this and make sure people are aware that this is something that we should be working on as an industry and something that we should be talking about more. And this works on both ends. End users and consumers of threat intelligence should be taking this stuff and building threat detection rules based on it. And vendors should be putting this stuff out there, whether privately or publicly. They should make it available in a machine readable format so that their customers can use this stuff for detection in the cloud.
Amazing. So if you want to read more about that, you can read the blog post. It's super interesting. They also talk about something called the pyramid of pain, which interesting. Got to know what the pyramid of pain is. Where do you lie on the pyramid? Open the blog post and find out. Thank you for joining us on this episode of Crying Out Cloud. Amitai, do you want to give us a little quick recap of the most important takeaways of today?
So for the Nvidia Container Toolkit vulnerability, as we mentioned before, this is an important vulnerability, especially if you're developing with AI. You should patch this while prioritizing cases where you're running untrusted images using the Container Toolkit. For the CUPS vulnerabilities, you probably don't need to worry about this too much if you're thinking about protecting cloud environments. But the best thing you can do at the moment is just disable it wherever possible, unless you're actually using it. Look for machines in your environment that are publicly exposed on port 631 and disable that port, or patch, because patches are slowly becoming available. For Infostealer mitigations by Google, if you are a GCP customer, we recommend at least trying out a CBA, certificate-based access, just because it makes it that much harder for Infostealers to steal your cloud credentials. And if you are a threat intelligence consumer or producer, we highly recommend learning about cloud IOCs and making them a part of your product and a part of your workflow.
Solid 10 out of 10. So, thank you. If you enjoyed the show, please subscribe. It's super easy. Just push subscribe and share a link to the podcast. Oh my God, tell all your friends and coworkers about it and share that. Do not share your cloud keys. And as always, if your cloud security strategy is making you cry, don't worry, just cry out cloud.